Hello everyone. Today I thought of sharing with you a problem that I encountered in counting. Suppose we have a 8 cross 4 grid. Consider that this is a 8 cross 4 grid, meaning 8 rows. 1, 2, 3, 4, 5, 6, 7 and 8. And you have 4 columns. 1, 2, 3 and 4. There are 16 ones given to you. 16 ones. You have to place these ones onto the cells of the grid in the following condition. By satisfying the following condition, first, exactly 2 ones in each row. Second, 4 ones in each column. If you try to count, 8 rows are there with 2 ones in each, 8 twos are 16 ones. They are all filled up. Or column wise, 4 ones in each column, 4 fours are 16. So you again get all 16 ones filled up. I actually encountered this problem when I tried to mathematically model a certain real life situation. The question is to find the number of ways to perform this. Find the number of ways to perform it. Alright, you can spend some time beforehand as you listen to the solution, but do not completely listen to the solution before giving one single try, at least, maybe for half an hour. First, let's fill the ones column wise, starting from the first column. In first column, we need 4 ones, and you can choose any 4 out of the 8. Let's say I choose the 4 as shown. The number of ways will be 8 choose 4. Now to count the remaining 3 columns, we will take case-wise analysis. In case 1, we will consider none of the ones in the second column match up with the same row as that of the first column. That means you have 4 such valid spaces, so you have to fill in the ones in those spaces. And that will be 4 choose 4. Now for these choices, I have to fill in the third column. That will have 8 choose 4 choices. You can fill in any 8 of them with 4 ones. Let's say I fill it up here in this way. Then clearly the other ones in the fourth column, the D column, is predetermined, because you should fill it up in such a way that each row contains 2 ones, and that will make sure you have only 4 ones, because we have filled up 4 ones in the first 3 columns. That leaves us with 4 ones in the last column. This is the counting. Next, case 2. Let's erase the third column and fourth column entries. In case 2, we will consider exactly one of the ones match up with the same row as the one in the first column, whereas all the other ones in the second column does not match with the rows of ones in the first column. Now there is 4 choose 1 way to choose for the one occurring in the same row. There are 4 choose 3 ways to choose the ones that does not occur in the same row as that of the ones in the first column. After filling these, I am predetermined with the empty row. Like you have the first 2 unit cells empty in the second row, which means the next 2 should be filled up by 1. So this gives us only 3 ones in the C column, the third column. So for the 3 ones, you have these 6 unit cells in the third column, and that gives us 6 choose 3 ways. And now if you fill it up with the 3 ones, then you are left with 3 ones in the fourth column, and that fills up the other 3 spaces. And that's it, you are done, because you have filled up already 2 ones in the first 2 columns of the first row. Alright, now similarly working with the third case where 2 ones share the same row as that of the ones in the first column, and other 2 does not share the same row. Now this gives 4 choose 2 ways to choose for the ones matching up the row, 4 choose 2 ways for the ones choosing that not match up the row, times you have 4 choose 2 ways for filling up the third column. And filling up the third column means you are going to completely leave out the cells in the first 2 columns of each row that are either filled or left empty. So that means I'm going to just cancel out these as they are predetermined. Now I'm left with only 4 choices for the third column. This is exactly why I inserted 4 choose 2. Now again, the fourth column is predetermined. Following this case-wise analysis, you get 4 choose 1 times 4 choose 3 into 2 choose 1 plus 4 choose 4 times 0 choose 0, that's like 1. That's when you have all the ones aligned and all the empty cells aligned. That will predetermine both the third and the fourth column. Alright, let's compute these case-wise analysis. Upon computation, you get 639, and now you have to multiply it with 8 choose 4 because that's the number of choices for the first column. We filled up the 3 columns in 639 ways for a particular given configuration of first column. So this is just 8 choose 4 times 639 to consider if you consider all the cases. And that's 70 into 639, which is equal to 44,730. This is the number of ways in which you can fill up the 8x4 tables. I hope you have different ways of tackling this. Let us know in comments. We will meet in another problem solving. Thank you everyone. Bye.